Now, so what will happen now? I plus, if you solve it now, so what happens? 2i is equal to what? 2i is equal to dm plus a, or I can write I is equal to a plus dm by 2. Okay, this is the second formula. This is the second formula. This is the first formula, second formula. So now I got I value. So, okay, quickly copy this one, then we'll go to the next. Now here, yeah, we'll do now sign news. So that is n21. N21 is equal to n2 by n1. So what is that? Sine of sine I by sine r. Okay, that is sine I by sine r. So what is n21? Sine I, sine of a plus dm by 2 divided by sine a by 2. Okay, sine of a plus dm by 2 by sine a by 2. When angles are small, n21 is equal to a plus dm by 2 divided by a by 2. This and this will go away. N21 is equal to what? N21 is equal to a plus dm by 2 divided by a. So that will become n21 minus 1. If you simplify, is equal to what? Into a is equal to dm. Okay. N21 minus a into dm is equal to, into a is equal to dm. Understood now?
Yes, sir.
So this completes your derivation. So these are, how many are there total all formulas? First formula, second formula, this is third formula, and this is the fourth formula. So definitely one question will be asked. Suppose if the, like in one of the board examination, they directly ask the derivation. But in some of them, in the other one, they are asking the numerical based on these formulas. So these four formulas which are in the box are very important. These four formulas which are in the, you can write it later on. After the derivation, you can write this together, all these four formulas. Okay, now we'll start with microscope now. So anything else remain here in this? So you have the definition, right? I have to discuss that graph. There is a small graph there that I need to discuss. Then directly I can go to the last part of the lesson. Spherical aberration.
After this is that what continuation. After this formula.
Yeah, after this is the continuation.
So 4 are the total.
Yeah, starts from here, then goes to this, then goes to this, then last.
Four formulas.
Four formulas for that from this derivation.
Can you explain this part? I didn't see.
See here what happens. We have I value, right? I came from here. And R came from here. R came from here.
The DM where it came from?
DM, no, we substitute in the place of delta, we put DM.
Okay.
What is the DM? DM is angle of minimum deviation.
Yeah.
Angle of minimum deviation means at a particular angle, what will happen at a particular angle of incidence? This refracted ray will become parallel to the principal, parallel to the base of the prism.
Yeah.
At a particular angle of incidence, this refracted ray will become parallel to the base of the prism. Yeah. Then what happens? These two angles will become equal. R1 will become equal to R2, and I will become equal to delta. E. I will become equal to E, and R1 will become equal to R2. Understood now? Yeah. So that is the way to do it. Okay. Now, yes. Now. Shall we go with the next derivation?
Yes, sir.
Okay, we'll go with the I mean the graph. We'll do the graph which is connected with this. So then quickly up. This is important for your practical also, prism experiment. Okay. Now. Now. See, here we have, this is the graph. So angle of incidence versus delta. Okay, this is I versus delta. So if you look at the graph is like this. The graph is like, so at that particular angle, what is that? It is somewhere on 40 here, somewhere at 40. This is 40, it is showing 40 degree, and that is showing around 40, 50 around. So what happened at a particular angle of incidence? This is 50 degrees. At a particular angle of incidence, what happened is the angle of deviation is delta. Okay, at a particular angle of incidence here 50. So the angle of deviation is 40. Understood? Is that clear? So what happens is we are actually this thing, the prism is kept on a table. That is said to be prism table. So now what happens is when you start rotating the prism table, the light which is hitting the surface is same. But what happened is the light we are not changing. Only the prism surface is tilted like this. So what happens when you are tilting the prism surface? Example, just I will take this one example here. See here, this is the prism surface. Like these are the two surfaces of the prism. This is the light hitting on the surface. Now, when you are slowly rotating this, and the refracted one is formed here. The line is formed here. Is that clear? Once again, light incidence on this part, and here the other end, the line is formed, like a bright line is formed here on this one. It doesn't mean that it is found on the screen. It is found on the surface of the prism. Now, what happens is when we are rotating this one, okay, when we are rotating this one, when you are slowly rotating this, the line which is formed on the other surface, it starts moving like this. It starts moving like this, and at a particular angle, when you are still rotating, the line, instead of going forward, it will start coming backward. That point at which it starts coming back is said to be angle of minimum deviation. Is that clear? That is why you see the curve in this way. Got it? It starts coming back. The line starts coming back. Okay, it goes forward and starts coming back when you're still rotating the prism. Got it? Is it clear?
Yes, sir.
Yes, sir.
Yes.
Because that experiment is not just so you're not doing. Otherwise, it's a very beautiful experiment we do in the graduation, higher level. So that is said to be angle of minimum deviation. Please do copy this graph. Then we are done with this. So we can start with optical instruments now. See here, we have in optical instruments. In optical instruments, we have two are there. One is microscopes and telescopes. Okay, microscopes and telescopes. So in microscope, we have two. What is that? We have simple microscope. We have compound microscope. Here we have two. What are they? We have reflecting and we have refracting. Sorry, terrestrial and astronomical. Yeah. We have two, that is terrestrial and astronomical. Two are there. Okay. Again, in astronomical, we have reflecting and refracting. Reflecting and we have refracting. Is it clear? This is the classification of telescopes. So we'll start with the first telescope, first one. That is simple microscope. Okay. So simple microscope is basically a magnifying glass. Compound microscope is the one which we use in the labs, bio labs. And terrestrial is for to see far objects. Have you seen the Bahubali movie, Ashas?
Yes, sir.
Yes. So that the king will be seeing the enemies, no? And he put one glass over there, one lens over there in that.
Yes, sir.
Yeah, that is a terrestrial, like a doorbin, what we say, or you can say binocular also. So that is a terrestrial telescope.
Sir, with multiple lenses.
Multiple lenses, but we want to see something on the ground, not in the space. Okay. The thing which we want to use in the space, that is astronomical. Okay. Here, so that is astronomical. That is we have reflecting and refracting. So in reflecting we use mirrors, and refracting we use lenses again. So in our syllabus only we have reflecting, one refracting, and two simple and compound. 4 are there. Okay. 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 So now here I have,
Sir, can you just tell that once again because I was writing.
okay, okay. You have that in the notes, no? Just go to the notes. Go to my notes. It is there.
Yeah, sir.
Classification is once again in optical instruments we have microscopes, telescopes. Then in microscope we have two. What are they? Simple and compound. In telescopes we have terrestrial, astronomical. Terrestrial and
Yes,
astronomical.
sir.
And again in astronomical we have reflecting, refracting. Okay. So that is how the class.
Yes, sir.
Okay, that is how the classification takes place. Okay, now so here we have in simple microscope. I am going with simple microscope. In simple microscope, how it is now? This is the object. So what happened here? There is an object which we are placing. OJ is the object. They are going to place. So there are two rays. A ray which is passing through optical center goes undeviated. Okay. One second. Okay, so here what happens? There are two rays. What happens? A ray which is parallel to principal axis after reflection passes through the optic center. The second ray which is parallel to principal axis, what will happen? Yeah.
It passes through for principal focus, right? It will pass through
A ray which is,
F.
yeah.
It will pass through F.
So it passes through F, right? So it passes through F, the focal point. Okay. A ray which is parallel to principal axis after okay. So now here what will happen? A ray which is parallel to principal axis after refraction passes through optic focal point. The second ray passes through optic center goes undeviated. So this distance is what? This distance is u, and so here what will happen? Just take these two rays backward. Okay, these two rays backward where the image is formed. Here, what is that? This is IG, or we can write AB or AB dash, something like that. Okay. Now u is the object distance and U is the object distance. Sorry, and D is the least distance of distinct vision. So when okay, now I is focused on here. Where is the image? I is focused on near point. Okay, so what happens here? D is equal to least distance of distinct vision, that is 25 centimeter. What is the definition of least distance of distinct vision? The minimum distance from the object, from the eye to the object, where the object is seen clearly. That is said to be what? Least distance of distinct vision. Okay. Now that is 25 centimeters. So that is M is equal to what? M is equal to V by U. We have this formula. So that is what we have V. And what is the formula? 1 by F is equal to 1 by U, 1 by V minus 1 by U. This is the formula. So we have 1 by U. 1 by U is equal to what? 1 by V minus 1 by F. Okay. So we are going to substitute that 1 by U value here. 1 by V minus 1 by F. Clear? This is the formula, and directly we substitute 1 by u value here. So we got this value. Now what happens here? M equal to B by V minus V by F. So this and this will be there. So M is equal to what? 1 minus V by F. Okay. So that's a formula. So we can also write M is equal to 1 plus D by F. Understood now? M is equal to 1 plus D by F. So therefore, what is that? V is equal to what? Minus D. Is it clear? V is equal to minus D. Now, now when the image is formed, now this is the near point. So what happens is when we are doing some experiments in the lab, it will be like the eye will be paining when the image is formed at D. Okay, the eye will be paining. So we want the image to be formed at infinity. So when the image is formed at infinity, then the full day you work on the lenses, nothing will happen to your eye. It won't be painful. So that adjustment is said to be normal adjustment position. That type of adjustment is said to be normal adjustment position. Once again, I repeat, what is normal adjustment position? The normal adjustment position means, okay, so the normal adjustment position means the, you know, that is arranging the lenses, or arrangement is made in such a way that the image is formed at infinity. The object, or the distance between the object and the image, is arranged in such a way that the image is formed at infinity. That is said to be, that is said to be normal adjustment position. Now here we have, so we will do that also. Now here what will happen? Here if this is the thing. Now here the object is at focal point. So what will happen? A ray which passes through optic center goes undeviated, which goes like that, and the second ray passes through the focal point. This also goes like this. So F is the focal point. Okay. So now here H is the object and F is the focal length. F is the focal length, and theta I is what? Here theta I, this is also theta I. Understood now? Now, so here what happens now? This is the eye. Okay. So image is seen from here. So eye is focused at infinity. Eye focused at infinity. This image is formed at infinity now. In that situation, what will happen now? Image is formed at infinity. In that situation, the first one is 1 plus D by F. We got it. Now directly we will use this formula. What is that? Theta I and theta O. So what is theta O? Angles. This is angle subtended by image and angle subtended by object. Theta I is said to be angle subtended by image, and theta O is what? Angle subtended by object. Theta O is angle subtended by object. So what do we have now? Tan theta is equal to what? Tan theta 0 equal to H by D. If the angle is very, very small, we can write here theta O is equal to H by D. Okay, theta is equal to what? H by D. Similarly, we have magnification formula here. What is that? M is equal to H dash by H, which is equal to B by U. This is also this magnification formula. Okay. So now what happens? Tan theta I is equal to what? Tan theta I equal to what? Tan theta I is equal to H dash by minus V. Okay, H dash by minus V, which is equal to what? So what is H dash now? So here we have now H dash is equal to what do we get now? H dash is equal to V into F by U. So that is V into F by U into minus V. So V and V will get cancelled, minus F by U. Okay, that is minus F by U. So here U is equal to what? Minus F. U is equal to, we got minus F. So implies what? Theta I value is equal to what? What is that? Theta value is equal to H by F. Sorry, this is, yeah, sorry. This should be H. This also should be H. So this will become minus H by U, which is equal to minus H by minus F. So that is equal to H by F. So here theta I will be equal to what? H by F. Okay. Theta is equal to H by F. So magnification formula is what? Magnification formula is theta angle subtended by image to angle subtended by object. So that is equal to what? H by F, which is equal to H by F which is equal to what? Divided by H by D. So H by D. So what will happen? H and H will go away and formula is D by F. Okay. So when the image is formed at infinity, we have D by F. And when the image is formed at least distance of distinct vision, then the formula is 1 plus D by F. I'll explain again from the beginning. This is simple microscope. Okay. In simple microscope, what is happening? This is the OJ is the object. And then what happened? We are taking two rays, a ray which is parallel to principal axis after refraction passes through focal point. Second ray which passes through optic center goes undeviated, take the rays backward, image is formed here. And this is U and this is D. Understood now? U is the object distance, D is the least distance of distinct vision. Now, D is 25 centimeter. What is the definition of least distance of distinct vision? The minimum distance from the eye for which the image is very clear. Okay, it can be seen clearly. So that is least distance of distinct vision. The formula for M is equal to V by U, and 1 by U, you have the formula 1 by U is equal to 1 by V minus 1 by F. Then we substitute here, and we have 1 minus V by F, and V is equal to minus D. We will get the answer. Similarly, after that, what we have here, this is the second one where the image is formed at infinity. Theta is angle subtended by image, angle subtended by object. Tan theta 0 is equal to H by D, theta 0 is equal to H by D. And here this is the magnification formula. Tan theta 0 is angle subtended by object, theta is angle subtended by image. So we are going to substitute H dash value here. We cut all the values, we get this one. Okay. Then we have theta I, we have theta O, both the values. Substitute there. This is said to be angular magnification. Angular magnification is angle subtended by image to angle subtended by object. Okay. So we got that formula is for when the image is formed at infinity. Understood? Is it clear?
Yes, sir.
Okay. Please do copy this one. Then we'll quickly go with the